What's that?
On my quiz, can I have it back to see what I did wrong?
They're in the black tray. You can always have your stuff back. You just have to go through it so you find
I'll do that then.
it. Okay.
Did you
Okay.
like mark what was on it?
Slash,
Or like,
yeah. Alright, so let's go ahead and get started on this, cause we got, the board over here to the left has got part of it right, but nobody got it completely right, so let's talk about it. Y'all's -8 is right over there, that's good. The problem with the substitution on this one is it's not ready. So you gotta get it ready, so you could say, and this is what Jalen was working on the top one, she was solving the top one for one of the letters, and you could do that, like move the 7y over and then divide by 2, but that's gonna make everything be fractions, but it's doable. It'd be easiest to solve the bottom one for y, because then you wouldn't have any fractions. So that's what I'm gonna do. I'm gonna subtract that 5x from both sides. So, everybody needs to get this, because nobody had it completely right. Subtract that 5x from both sides. Now that's gonna leave you with -y is equal to -5x minus 39. Then what would we have to do to get a positive y?
Flip all the signs.
Good, divide by negative, which does just flip all the signs like Austin said. So now I can work with that with no fractions or decimals. Okay, so that's what y is. So I'm gonna take that and substitute it in right there for the y. Okay, so we're gonna have 2x plus 7, but instead of y, I'm going to put that quantity 5x plus 39 is equal to -23. Alright, what do we do now? Yes, ma'am, we're going to start distributing our 7 there. So it'll give us 2x plus 35x plus, is that 273 is what Leonard's got over there, is that right? 273 and then equal to -23. So now you got like terms to combine. So your 2x and 35x gets you 37x. Alright, so now we're finally to our champion phase here where we got a 2-step middle school equation to solve. What would we do first? Good.
So you're gonna be at 300.
So not quite, but close. Gets us 37x is equal to -296.
Oh, why I think we're at 7 on
And then divide by 37. And that should get you the -8. Right?
Yes, ma'am.
Oh, dadnabbit. Okay, so that gets us an x, and now we gotta take that x and go substitute it back in to get our y. And that's where y'all got a little fuzzy on. So this one will be the easiest place to substitute it in, so I'm gonna say 5 times -8. So you write down here y equals 5 times -8 plus 39. And then 5 times -8 is -40.
-1.
So that gets you a y of -1. So our final answer would be -8, -1.
Where's my X?
Okay, do we see where we went wrong along the way? Jalen just had a mistype and y'all just forgot to plug it back in. So everybody good? What'd you get there? Alright, let's hit mode. We'll change that to float. Alright.
Hey, Coach, can you scroll back to the top right fast?
My, first period class is, everything we're doing right now has to do with money, so they set that to do that.
Hey, Coach,
Yep,
can you scroll back to the top right fast?
you bet your boots.
This is so just the plastic umbrella is so
Okay.
Alright, I'm gonna clear that up, and then we're gonna get to my favorite method today, which is elimination. Then we'll even look at it with some of our good old word problems. Fun times, Jalen, fun times. Come on, eraser, erase. Let's go down here. Let's go here. What the heck? Okay. Alright, so solving systems of equations. So far, we're still looking at two equations with two variables, which means where the line crosses, which means they can cross one time and have one solution, or it means they can be parallel and never cross and have no solution, or it means it can be the same line and have infinite many solutions, okay? And so we looked at that by graphing yesterday, and I've told you graphing is my least favorite because it's not always precise. We looked at substitution, which works pretty good, and today's our third method, and it's my favorite, and it's elimination. But I still know how to use the other two methods because sometimes it's set up for one or the other, okay? So let's look here. I've got two equations. This one says x plus 7y is equal to 17. And then my second equation says x minus y is equal to negative 7. And notice how I wrote those? They're stacked up. I got my x over my x and my y over my y. That's how you're going to want to line them up when you do elimination, because elimination is just like it sounds. We want to be able to eliminate a variable, to get rid of a variable. And we're able to do that, Jalen, get it put up, when the variables have the same coefficient. That means the same number in front of the letter. So look at my y's. I got a 7y and a negative 1y. 7 and negative 1 are not the same. Okay, good on that? But on my x's, I've got a 1x and a 1x. That's the same. So that means I can eliminate them. And you got two choices for elimination. It can be with addition or it can be with subtraction. So what would eliminate those x's? Would it eliminate it by adding them?
yeah.
What's x plus x?
2x.
2x. I didn't eliminate it.
You have to subtract
Would it
them.
eliminate it if I subtracted them?
Yeah.
Yes, x minus x is nothing, right? So we're going to put a big subtraction sign here between these two problems and then draw our line, and now we're going to subtract just like we did when we were a little tot. Okay, so on my x's, x minus x, that's nothing. He gone. We eliminated it. Move over to the y's. 7y minus negative 1y. Did you see that? Pay attention to your signs. 7y minus negative 1y is what?
6y.
Nope.
Wait, say that again.
7y
Oh.
minus
8y.
negative 1y is 8y.
Oh.
And now pay attention over here on these signs too, because it's 17 minus negative 7.
Wouldn't it be 24?
24, very good. Look at this, we've almost got our y.
Y equals 3.
Yep, divide by 8. And y equals 3. Way easier, way faster than what we've done so far.
I like this
But
one.
this one was ready for that. Keep that in mind. But we're not done. Now, what are we going to do with this y equals 3 to get our x?
When you plug
Plug
it
it
back
in
up.
one of them. Doesn't matter which one.
No.
Do the 7 one.
Okay, the 7 one. So I'll say x minus, but instead of y, I got a 3. That's just one step to solve that. What would you do to solve that?
What's 3?
Add a kid.
So it'd be negative 4.
Yes, it would. Good job. Final answer. Make sure you put them in the right order. winner chicken dinner. Elimination is easy when it's ready.
I don't know when it's ready, yeah.
Yep.
I thought you were saying it's easy regularly.
You haven't seen one yet. It might be. It might be.
I don't know. It should be some Sonic.
Alright, got what you need on that one? Let's do another. Whoop, whoop.
That's elimination, correct?
Yes, elimination.
12-foot short phone.
12 foot? I don't think so. I think they're more like 12 inch.
Hey, if it's through the 12 foot, I'll get it.
You wouldn't be able to carry it.
It's how it
Tell
would.
you what, you know how long 12 feet is?
Yeah, it's like 4 feet taller than Blake. 6 feet. I don't know if I'm around.
What are you trying to carry that
He
small?
said he's gonna get a 12-foot chili cheese dog.
Yeah.
You would not be able to get on that.
Dude, your body physically cannot handle that.
He couldn't even carry it.
I probably should.
No, I mean, you could try to carry it, but it's unbelievable.
How big?
12 feet.
That's basically
It's
two
like
of
this
me.
wide. It's like this wide.
That's two of me still. You're
You
not gonna
cannot
be able to
eat
carry that, nor eat it.
Okay, we got 3x plus 2y equals 22. Then we got 5x minus 2y equals 42. Okay, so let's look at our x's. I got a 3x and a 5x. Can I eliminate that? Good, Summer. They're not the same number, so I'm leaving them alone. Go look at your y's.
Well, so you couldn't just minus the 3 and stuff and make it negative 2?
But I'm trying to eliminate something.
What,
So let's go look at our y's.
What,
Well, yeah,
wouldn't
can
you
get rid of
add?
one.
Yes. Okay, I got a 2y and a negative 2y. 2 and 2 is the
Yeah.
same. So yes, I can get rid of them. Riley and Austin are already talking about this time it's going to be addition.
Wait,
Is-
why?
If
Good
you add a
question.
negative to a
What's 2
positive,
plus negative 2?
0.
And that's what
but
we want.
you said you gotta minus it.
If I subtracted, what's 2 minus negative 2? I didn't get rid of it.
4.
So you get to do whichever one works for you. So this one, it's going to be addition. And here's the mental note to make. Look at the last problem and look at this one. The last one we subtracted, they had the same signs, right? This one we're adding, and the letter we're eliminating has different signs. Did you see that? So if the letter you're eliminating's got different signs, you'll add. If the letter you're eliminating's got same signs, you'll subtract. Okay? So some of y'all see y'all feverishly writing, have already gone to work. 3x and 5x is
And same size.
same sign subtract. Yes, ma'am.
That would be 8x.
8x. 2y plus negative 2y, that's nothing. He gone.
64.
22 plus 42 is 64. Pretty sure we already know our x.
So
Mhm.
can
Yes,
we take
sir.
that one and plug it into the 3?
And then you gotta plug it in.
Right, gotta plug it in. It doesn't matter which one. Austin picked the top one. So 3x, so 3 times 8. 3 times 8 is 24.
Oh, that's why.
Okay, two-step middle school equation game.
Minus 24.
Minus
negative 2.
24.
Wouldn't that be
So y
46?
equals negative 1.
Where are you getting 46, Hot Rod?
Just kidding, that'd
Okay.
be negative 2.
Oh, you were ahead of me. Just kidding, she said.
I think.
Yes, 2y is negative 2. And then we divide by 2 and get what Riley said. So 8, negative 1. Bada bing, bada boom. Pretty cool, huh, Leilani? Mm-hmm.
That's not cool. We need you.
Alright, so now let's look at what happens when it's not ready. Okay? Let Hunter get caught up. Hunter in the hood. Alright, so this one I've got 4x minus 9y equals negative 42. And then I got x plus 5y equals 4. Okay,
Oh.
so just just some thoughts first off. You could get that second one, get the x all by itself by subtracting 5y and do substitution like we did yesterday. That's an option, you could do that. It's just like the bell ringer. I want us to do it by elimination. So we look at we look at our x's and we got a 4 and a 1. That's not ready, is it? We look at our y's and we got a 9 and a 5. That's not ready, is it? Get it put up, Riley. So I gotta get it ready.
My dad told me after
We're in math class. Tell your dad, your teacher, is going to take your phone away.
Okay,
Put the phone up. I got to get it ready. So I got to look at my x's and say, what can I make my x's be that would be the same? Could I make them both 4s? Yeah. Look at my y's and say, what could I make my y's that would be the same? What's the smallest thing 9 and 5 will go into evenly? It's not a trick question. What will 9 and 5 both go into evenly?
1.
No, 1 will go into them. What will they go into? 45. So I could multiply, we're not going to do this, but I could, don't write this down, I could multiply this whole top equation by 5 to make my y 45, and this whole bottom equation by 9 to make my y 45 and eliminate them that way. I could do that. But since the top one on the x's already has a 4, I can leave that one like it is and just multiply the bottom one by 4. Okay? So I'm going to rewrite my top one so that I can have them stacked up. So this is what we do when we're not ready. Now I'm going to distribute my 4. To get our x's with the same coefficient. So we can eliminate them. Okay, so now both of my x's are 4s. You with that? Am I going to add or subtract?
Subtract.
Good.
Would it be
ahead,
20y?
Yes, I forgot my y there. Thank you, Austin. Good save. Good eye. Alright, so we are subtracting. 4x minus 4x is nothing. He gone. Negative 9y minus 20y. Negative 9y
Wouldn't it be
minus...
positive 11y?
No.
Negative 11.
No.
Wait, negative 20.
Negative 29y
Oh, what?
Oh.
I did not know.
equals negative 42 minus 16.
Negative 15.
Negative 58. Last step, figure your y.
Divide by negative 20.
Divide by negative 29. And y is 2.
What about our A? What about X?
Now we got to go find our x. You're right. So,
Plug it into the top one.
I mean, you can plug it into any of the 2 original ones or any of the 2 new ones we used over here. I might plug it into this x plus 5y. There might be less work to do there, huh? So x plus 5 times 2 equals 4. If you chose the top one or you chose the other one, you'll still get the same answer. It's okay? That gets me x plus 10 equals 4.
Why did we minus 4x minus 9?
I could have plugged it in that one. Is that what you mean? Oh, tell me your question again.
And the problem over there, 4x
Uh-huh.
minus 9.
Yeah.
Why don't we do that?
It already had a 4. I didn't have to do anything to it. So the top one I didn't have to change. It already had a 4. So you got a negative 6. Alright, let's look at a tougher one.
Did you also plug it into the 4x?
Yes, so that would have gotten you 4x minus 18 equals negative 42, right? Is 9 times 2?
I got 4x equals 60.
You got 4x plus, oh, you put this one, my bad. So 4x plus 40 equals 16.
I thought that was the
Yeah,
answer.
yeah, okay.
You did that one?
Yes, you could. I thought you were going to tell me you got something different and I was nervous. Whew. Alright, let's look at a tougher one. That was that one. Let's do a tougher one. I've got here 5x plus 3y equals -7. And then I got 2x plus 7y equals 3. Yes, -7. Alright, so look at your x's. 5 and 2, that's not the same, not ready yet. Look at your y's. 3 and 7, that's not the same, not ready yet. Now in the last problem, we were able to keep one of our equations the same. Like we kept that top one the same and just multiplied the bottom one. Could I do that here? Is there something times 2 that gets me 5? Not a whole number.
Oh, just kidding.
You're ahead of me. You're ahead of me. Is there something times 3 that gets me 7?
Nope.
Not a whole number. So I'm going to have to multiply both of the equations by something this time. So Kinley's already on the right road. She's looking and saying, well, you could make these x's, 5 and 2, both going to 10. So you could make both of your x's be 10. That's good. Y's, if you wanted to get rid of the y's, you could make them be 21. I would probably go with Kinley on the 10 because it's a smaller number. Go ahead, Kinley.
So would you times the last one all by 5?
So on the top, we've got a 5x. To make that become a 10, we have to multiply all of it by 2. And then on the bottom one, we got a 2x. What would we have to multiply it by?
5.
Very good. So on the top, let's distribute our 2 to everything. Gets us 10x plus 6y equals -14. A lot of people will forget to multiply the equal side. Don't forget that. Okay, then on the bottom, we got a 10x plus 35y equals 15. Okay, we got x's the same, so we're ready to draw our line. Are we going to add or subtract? Good job. 10x minus 10x is nothing. He gone. Well, it's a positive 3 and a positive 5. It should be positive 15. Did I write it down wrong? Write it down wrong? Okay. That's okay. I'd rather you tell me than me do it all wrong. 10x minus 10x is nothing. He gone. 6y minus 35y.
29. Negative 29.
Negative 29y. Good. Negative 14 minus 15. Negative 29. Hey, I think we know our y.
1.
Yes, ma'am. Okay.
Yes.
Now you just gotta find somewhere you like to plug that in. You want the 5x, the 2x, or one of the 10x's?
10x.
The 5x.
Fuck.
So 5x plus 3 times 1 is equal to -7. So 5x plus 3 is equal to -7. Two-step middle school equation. Subtract 3. 5x is -10. And then divide by 5. And x is -2. Don't forget to put them in the right order. Hot dog, hot diggity dog. 12-footer. Alright, so the next, when you finish that one up, the next few things that we're going to look at is how to set one of these up out of a word problem. Because that's the fun stuff. For real. Oh, well. Alrighty, so we got here, good old Marcy's buying a total of 20 used books and CDs. So I'm going to go ahead and say my B is going to be books. And my C is going to be CDs. So I know she's buying a total of 20. So the number of books she buys plus the number of CDs she buys has to equal 20. You okay with that? I just wrote that equation. They didn't give it to me. You okay with that? Total number of books and CDs Marcy bought was 20.
Like $20?
No, 20 books, actual physical books. We haven't talked about money yet. So she bought a truckload of books and CDs.
What is the rollerblade problem?
Say it again.
What's the rollerblade problem?
Oh, I haven't read it all yet, I'm sorry. You ready for me to read the rest of it now? Jalen is. So,
I was gonna write it down.
Marcy bought a total of 20 used books and CDs during a yard sale for, here's the money you were asking about, Kenley, for a total of $54.50.
How much?
$54.50. Books cost $1.50 each. So I'm gonna say $1.50 times the number of books. CDs cost $5 each, so $5 times the number of CDs, and that has to equal the total she spent, which we said was $54.50.
Well then, why would you have the 20 right there?
Because that's how many total numbers she bought. So my top equation deals with just the number of, and my bottom equation deals with the money. Hello? Yeah? Some of them I would, but some of them I still don't know yet, but I do know some of them. Yeah, yeah. Okay. Yeah. Yeah. Right. Okay. Alright. Okay, so now we've got our system of equations set up. But it's not ready to eliminate anything. My B's, I've got a 1 and a 150. My C's, I got a 1 and a 5. So I'm going to have to multiply one of the equations by something. I could make my B's both be 150, or I could make my C's both be 5. Okay, that would make more sense with a whole number. So that means we're going to have to multiply all the top equation by 5. Because we're getting ready to eliminate the C's. So it's going to get us 5B plus 5C equals 100. Now this time we don't have to multiply the second equation by anything because it's already got a 5C. Is this going to be addition or subtraction?
Subtraction.
Good. So what's 5 minus $1.50? 350B. 5C minus 5C is nothing. He gone. What's 100 minus 5450?
45.8.
Not 80.
0.8.
No.
Wait, what?
It's you're subtracting 50 cents. You're not going to get 80 cents.
Oh, I thought it was 26.
So 45.50. Is that what everybody got?
1, 6, 1 minus.
Okay. So what do we do to solve for B now? Divide by 350. And you got B is what? 13. Okay, so what we found so far is how many books she bought. Out of the 20 things she purchased at the yard sale, 13 of them were books. So what does that mean? How many were CDs?
You don't know.
Yeah, you do. She bought 20 things.
7.
7, there you go. You got it, sister. Well, we just go back up here to our first one and you plug in the 13 right there. 13 plus C equals 20. So subtract your 13. Alright, let's do 2 more of those. They go on in. Alright, I'm going to read this one all the way through first this time, Ellen, and then I'll make some notes. So Landon babysits and works part-time at the water park over the summer. So probably going to be thinking about babysitting and water parking. One week he babysat for 3 hours and worked at the water park for 10 hours. He made $109. The next week he babysat for 8 hours, worked at the water park for 12 hours, made $177. How much does he make per hour at each job? Alright, so the first week it said he babysat for 3 hours. So I'm going to say 3 hours times B for however many babysitting he did. That same week, he worked at the water park for 10 hours. And he made a total of $109 that week. Okay? Could you write that equation? Could you do that? 3 hours babysitting, 10 hours working at the water park, he brought home $109. Okay, then the next week, he babysat for 8 hours. He worked at the water park for 12 hours, and he brought home $177. So how much does he make per hour at each job? Alright, so is there a letter that's ready to eliminate?
No.
No. Is there a way I can get away with only having to multiply one of the equations? Could I make both of the B's be an 8? Could I make both the W's be a 12? No. So I'm going to have to multiply both equations on this one. So looking at the B's, I think the smallest thing they both go evenly into would be 24. So I can make them both be 24 B's. Looking at the W's, 60. I can make the W's, the smallest thing is 60. So what do you want to do? 24 on the B's or 60 on the W's?
24.
Okay, so the first one's got a 3B. What am I going to multiply that by? 8. The second one's got an 8B. What am I going to multiply that by? 3. So let's get to the distributing. Gets me a 24B plus an 80W. What's 109 times 8?
That would be 870.
Thank you, ma'am.
Oh, what the?
Okay, now I'm going to go with the 3. So I got a 24B. 36W. And what's 177 times 3?
531.
531. Alright. So are these two equations going to be added or subtracted? Subtract 24B minus 24B is nothing. He gone. 80W minus 36W. 44W. Whoops, where's my marker? There it is. And then 872 minus 531. 341. Summer is on it.
Divided by 44 would be 7.75.
Okay. And that's money, so that's W. So at the water park, he makes $7.75 an hour.
I feel bad for that dude.
Okay, so now we gotta figure out how much she's gonna get paid babysitting. So we gotta take that $7.75 to one of our equations and plug it in for the W. You wanna do the 3B, the 8B, or one of the 24Bs?
3D.
The 3B has got 3B plus 10 times W, but we got 775 equals 109. Can you remember I got a 109 there? I'll scoot it over this time. 3B plus 77.5 is equal to 109. 10 times 775, right? Just moves the decimal. Okay, now is your two-step middle school equation.
Wouldn't it be 50? 0.50?
Oh, yeah. So I'm subtracting the 77.50. Makes it look like 6. So I got 3B is equal to what? What's 109 minus 77.50?
3150.
3150.
Oh, I'm so, oh my.
Then divide by 3. And you got B is what? $10.50 an hour. So it gets paid $10.50 an hour for babysitting. Gets paid $7.75 an hour at the water park.
1050 order.
You good?
Or park.
Hold on just a
You got it, sister.
second.
Yes.
Did you get 10.5?
Yes, $10.50. Good job. All right, I just got one more.
One last.
Okay, we got here Kent has a collection of pennies and nickels, so I'm probably gonna have a P and an N, with a value of $1.98. Okay, so value, that's talking money. So pennies, how much is a penny worth?
1 cent.
1 cent, so 0.01 times my number of pennies, plus what is a nickel worth?
5.
So 0.05, my number of nickels, and it said he has $1.98. Okay, so however many pennies times a cent, however many nickels times a cent, gets him $1.98. Okay, now this part of it's different. The number of pennies he has is, so that says P is, which means P equals, the number of pennies he has is 5 less than twice the nickels. 5 less than twice the nickels. Look what we just wrote there.
Hey, it doesn't line up.
It does not line up. So here's our options. We could move the stuff around, subtract the P and add the 5, or subtract the 2 in, whatever, move stuff around. Or you could do substitution. This one's ready to substitute. What we did yesterday. If P is that, take that and substitute it in for the P. So let's do 0.01 P. So instead of P, put your 2 in minus 5. Plus 0.05 N is equal to $1.98.
What are we trying to figure out?
How many pennies and nickels he has?
Oh.
Okay, let's distribute our 0.01. 0.01 times 2, that gets us 0.02 N. 0.01 times 5 gets us 0.05. Okay,
And when you combine like terms,
now good, Austin, we got 0.02 N and 0.05 N. That gets us 0.07 N. Okay. Oops. Now what would we do?
add the 0.
Good, add that 0.05.
I must,
0.07 N is equal to 2.03. And then last step here.
Oh. I'm confused.
Okay, talk to me.
I got to that point and I divided 2.03 divided by 0.07 and I got 29.
That's correct. That means he has 29 nickels.
Oh.
He's got a lot of nickels.
Nickel.
Yes, you can. Is that far enough or more? Okay, so we know how many nickels he has. As soon as we get caught up on that, we're going to go figure out how many pennies he has.
So we just plug it in for N?
Uh-huh. So I'd probably go to that P equals 2N minus 5, right? P equals 2 times 29 minus 5.
That was really 52.
53. So he's got 29 nickels and 53 pennies. Good deal, Lucille. Okay, so what we're going to do with this tomorrow is some more practice. Tomorrow I'm going to have you some word problems to do on your own, like we just did. Okay? They all right with that? I mean, you don't really have a choice, but so might as well just say you're all right. Yeah.